So here, if we take a look at the diagrams down here, right? So we're still figuring out ways of how to go from polar to rectangular and vice versa. So if you take a look at this circle, right? This circle has a radius of 3, and you can see here 1, 2, 3. So in rectangular coordinates, the equation of it would be x squared plus y squared is equal to 9. Okay? Well, what would it be in polar coordinates? Yeah. We've talked about the fact that r equals 3 is the set of all points from the center that the radius is 3. And that's what spells out a circle. Okay? So if you take another look at this, this is a line, right? The equation in polar and rectangular coordinates for that line would be 2x minus 3y equals 6. In the polar world, the equation is that mess over there. So now, how do we go from one to the other? Well, we've already learned the basics. We've already learned that this is what our keys are, right? To go from polar to rectangular, we have two basic equations. X is r cosine theta, y is r sine theta. We're going to carry that along with us. And to go in the other direction, r is the square root of x squared plus y squared, and theta is the inverse tangent of y over x. So that's what we're going to use for everything else. In fact, so just repeating one more time, to convert from rectangular to polar, replace x with r cosine theta and y with r sine theta. All right? And then we simplify and all that good stuff. All right, so let's take a look at this first one. Yeah. Okay, so we're not going to need it exactly for this one right now. So maybe we could go over it for the later one. Okay, so here, basically, whenever you see an x, we're going to write r cosine theta instead. Whenever we see a y, we're going to write r sine theta instead. So let's do that here, right? So if you just take a look at this without doing anything else, what equation is this? Yeah.
R cosine theta.
No, this x plus 2 squared plus, it's not a linear equation. What is this the equation of? When you have x squared, y squared, and a plus in the middle, this is a circle. All right? So this is a circle. In fact, the radius is the square root of that number. Okay, and the center is h comma k. From here we get -2. And the y has nothing next to it, so it's 0. All right, so if you go back to your algebra 1, geometry days, the center, right? So if you go back to geometry, or even algebra 2, all that information you could get from just looking at this. Okay. So if you look at this number, the negative of that number, -2, will give you the h coordinate. And this is plus, like it's y plus 0. So it's -2 comma 0. That's how you get h and k. In geometry, you learned it in geometry. Okay, so if you have an equation that looks like this, x plus 3 squared plus y minus 7 squared is equal to 16. The center is -3 and +7. It's conics too, but you first learn it in geometry. Okay? And then the radius is the square root of that number, which is 4. Okay? All right. So now let's go back to our conversion from rectangular to polar. Okay, so wherever I see an x, I'm going to put in r cosine theta plus 2 quantity squared plus r sine theta squared is equal to 4. Okay? And now we simplify this. So when I square the first binomial, I'm going to get r squared cosine squared theta plus 4r cosine theta plus 4 equal to r squared plus r squared sine squared theta is equal to 4. Okay? Now, I subtract 4 and I subtract 4, so that goes away. Thank goodness. Okay? After you subtract 4, this is the critical step now, right? Because we squared an r cosine theta and we squared an r sine theta, now we have sine squared theta and cosine squared theta, and that is an identity, right? So what I do is this and this, okay? I'm just going to write them next to each other. Plus, what else do I have? 4r cosine theta is equal to 0. So now, from this blue part, I'm going to factor out an r squared. And I get cosine squared theta plus sine squared theta plus 4r cosine theta is equal to 0. Question, yes. Well, I just factored it out from here. You're free to factor stuff out from parts of this. Yeah, that's because mathematically it's acceptable, because when I put this back in, I get that back. So it's totally fine. Okay? Yeah. Daniel. It is, yeah. This is just going to be a 1, right? Because that's an identity from chapter 5. Sine squared theta plus cosine squared theta is equal to 1. So now I have r squared plus 4r cosine theta is equal to 0. And now we're almost there. What we have to do is we have to solve this for r. However, before we can even do that, can I divide everything by an r? Right? So I divide everything by an r. Why? Because you can and you should. That's part of simplifying. Okay? So now this gives me r plus 4 cosine theta is equal to 0. So this is r equals negative 4 cosine theta. No, because I didn't factor it out. I divide it through by r. So r is negative 4 cosine theta. Okay? Now, if we go back here, I'm going to go back in a minute. But here, take a look. So I got r equals negative 4 cosine theta, right? Is that or is that not a circle? That's a circle. So now it's one of these a cosine thetas, but a is negative here, right? So it's one of these. It's on the left. And what does a represent? The diameter, right? So going back.
Are you giving us that sheet on the back?
Yes. So this is a reflection around theta equals pi over 2, and the 4 is the diameter. Okay? So now if it's 0 here and 1, 2, 3, 4 units there, that's the diameter of this. The center is going to be at 2. That's the center, the middle of the diameter. So that's your circle. Okay?
What is
X and the y. Right? X and y are going to get replaced. So it's 2 times r cosine theta, r sine theta equal to 4. You could, yeah. No, you know what? Don't. Just hang on for a minute. Okay. So what is this? This is 2r squared sine theta cosine. So this is equal to 4. Now, here's what we're going to do. I'm just going to change the order of the r squared and the 2 here. All right, so I'm just going to write it as r squared out there. 2 sine theta cosine theta is equal to 4. Okay, now, Precalc also includes trig, and we learned trig, and we're supposed to carry it with us. Okay, so here, this is an identity. 2 sine theta cosine theta is cosine 2 theta. All right? So this is r squared cosine 2 theta is equal to 4. I'm sorry. It's sine 2 theta. I misspoke. All right? It's sine 2 theta. So r squared is equal to 4 over sine 2 theta. Okay? Now, more often, this is written as, 4. Now, what's 1 over sine? Cosecant 2 theta. Y equals x squared. When you just look at this, we're going to graph them later. I just need to get through this lesson. Y equals x squared. If you just look at this, what does that sounds like a parabola, all right? So, all right, so y is going to turn into r sine theta, and this is r cosine theta, and we're going to square. So now it's r sine theta equal to r squared cosine squared theta. All right. Anyway, we could solve that for r. Well, so let's divide by an r, because otherwise there is no way to solve for r. So r cosine squared theta is equal to sine of theta. That means r is sine of theta over cosine squared theta. Okay, now remember what I said is we don't want to do trig functions in the denominator. Well, let's see what we could do here. This is really sine over cosine times 1 over cosine, right? I'm just splitting up the cosine squared. So r is tangent of theta, secant of theta. Okay? Huh? Okay, so here we were going to solve for r, but there was no way. All right, so now to go from polar to rectangular, oh, by the way, we know that x is r cosine theta. We know that y is r sine theta. One thing I forgot to write here is that r squared is equal to x squared plus y squared. And then we were talking about tangent of theta before. Well, tangent of theta is y over x, right? That's one of the ways we convert from one to the other. So if I have a point, right, and I have the x coordinate and the y coordinate of that point, how do I find theta? Well, it's a right triangle, and theta is always opposite over adjacent, okay? So now, when we're going from polar to rectangular, it's helpful to keep all four of these in mind. So basically, these four are the key to going back and forth throughout this chapter, okay? So now, I have theta equals pi over 4. What does that look like, by the way? Theta equals pi over 4. The graph, what does that look like? It's a line, right? So it's a line through pi equals 4, like that. All right, now, I need to write this in rectangular form. In rectangular form means I need x and y, okay? All right, now I have theta, that's fine, but what I really need to go to x and y is tangent of theta. So what do I do here? I, just like in previous things, we all like taking the logarithm of both sides as a thing. We take the tangent of both sides, okay? So I say tangent of theta is equal to tangent of pi over 4. Okay? Why? Why did I do that? So what was the reasoning? Because I need x and y. What connects theta to x and y? It's the tangent. So I can take the tangent of both sides. Okay? One sec. So now, what is tangent of theta equal to? Here, what is tangent of theta equal to? It's y over x is equal to tangent of pi over 4. Okay? So now, tangent of pi over 4, it's just a number. That's just a constant. Right? What is it? It's 1. So y over x is equal to 1. Y is equal to x. Okay? And look, pi over 4, right? That's a 45-degree angle, and that's definitely y equals x. Yes. Because the key, right, the equation that relates theta to y over x right here, it's the equation that relates theta and y and x is tangent, because tangent of theta is y over x. So if I have a point xy right there, okay, how do I get to that point? I go x a little bit, and I go y a little bit. So now, what's that angle formed here? All I know is y and x. What's the measure of that angle? Tangent of theta is y over x. Okay? Yeah. Okay, so now, r equals 7. What shape is that? That's a circle, right? It's a circle with radius 7. Okay, so how do we connect r to our x and y? What's the connection? R squared is x squared plus y squared, right? So I need an r squared, but I only have an r. Oh my God, what am I gonna do? Square everything. So r squared is equal to 49, but what's r squared equal to? X squared plus y squared is equal to 49, and that is the equation of a circle. That's the equation of a circle, and remember what I said before is if you have the equation of a circle, the square root of the number at the very end is that. So there you have it. Okay? So 2, 4, 6, 8. So if that's 7, that is what that looks like. Now, okay, now, This one is a circle, right? How do we know that this is a circle? Because on that sheet of the cute little shapes, it says that this is a circle, okay? Now, so I need, if this is a circle, I need it to look like x squared plus y squared equals something, okay? Now, that means if I want x squared plus y squared, I need an r squared. So now look, and this one you just sort of, you're just going to have to memorize that this is how you do it. When you have r equals something sine theta or something cosine theta, we don't square both sides, we multiply both sides by r. So I remember when I used to take all these classes, my professors would, or my teachers when I was in high school, they would just do things, and it sounded like voodoo magic. And I was like, oh my gosh, how am I ever going to know how to do this? But trust me, after doing enough examples, I was just like, oh yeah, and now you just multiply both sides by r. Like, you just know, okay? So here, r squared is equal to negative 5r sine theta. Okay, this is one of my favorite things. So now, how does r squared connect to the rectangular world? X squared plus y squared is equal to minus 5. And what's r sine theta? It's y. Oh my gosh, look at that. Okay? Right? R sine theta is equal to y. So now, x squared plus 5y plus y squared. Wait, we read it this way. Sorry, hang on. It's x squared plus y squared plus 5y is equal to 0. That, believe it or not, is an equation of the circle. But you might say, you know what? You're just pulling my leg, because that is not the equation of a circle. Well, let's see. You guys remember completing the square? So look, it's x squared plus y squared plus 5y is equal to 0. Now, that loner of an x squared is all alone, so we don't need to touch it. Plus, these, though, they're together. We can add another term to this. So we do y squared plus 5y plus a number equals plus a number. Because if I add a number here, I've got to add another number there. Do we remember what number goes in that blank? You take 5, divide by 2, and then you square. So it's 6.25. So x squared plus, now we factor this, y plus 2.5 squared, right? We take the square root of this, we take the square root of that, square it, is equal to 6.25. Now look, the center is 0 and negative 2.5. The radius is 2.5. So, and look, oh my gosh, like I love this stuff. So we had gotten, okay, so this was negative 5 sine theta, right? Negative 5 sine theta, if you look here, is down here, right? It's down there. So now look, what did I find my radius to be? 0, comma, negative 2.5. And the radius is 2.5, so check it out. Come on, you can't not be amazed at this. Why did I draw that circle? Because the center is 0, negative 2.5, and the radius is 2.5. Think about it. Okay? Now, so this homework will be due tomorrow. Tomorrow I will I will show you how to graph these. If you get ones that look like this, you are allowed to not graph. But, like the circles and the lines, those you can graph. Okay?